Welcome to Calculator Corner. In this video, we'll find the area between two curves using the TI-84 Plus. So our two functions today are f of x is equal to x squared minus 2x plus 3, and g of x is equal to negative 1/3 x squared plus 4x plus 3. Now, this problem does not explicitly give you the x bounds, the left and right, where you're supposed to find the area between. Instead, these two curves intersect each other, and that creates a natural bound for you to find the area between them. So let's go ahead and graph these on the TI-84. I'm going to go to y equals, and for y1, I'll enter the f of x function, x squared minus 2x plus 3. Press enter. And for y2, I'll enter the g of x function. Negative 1/3, so 1 divided by 3, times x squared plus 4x plus 3. And press enter. Now let's go ahead and take a look and see what these graphs look like when graphed on the same grid. I'll do zoom standard. Standard is number 6, so zoom 6. There's one parabola, and there's the other parabola. And I can't quite see where the intersection is since the parabola goes off the top of the screen. So I'm going to change my window. For the x-min, I think negative 10 was too far to the left, so I'm going to change that to negative 5. We can leave that one at 10, the x max. X scale is just where the tick marks are, that's 1. Y min, let's change that to negative 5 as well. But for y max, let's try 20. And y scale, we can leave that as 1. And this time let's press graph so that the graph will use these numbers for the window boundaries. There's our parabola and the second parabola, and that's a great looking graph. We can clearly see where the two parabolas intersect. We need this intersection to determine what the bounds on the integral will be. To find the intersection of these two curves, I'm going to do second calc. I'm going to go down to number 5 for intersect. And the calculator wants to know what the first curve is, and I'm already on the first curve. And then it wants to know what the second curve is, and it automatically went to the second curve. Now it wants a guess. Now this is important. Since I have two different intersection points, I need to scroll over and get closer to my first intersection point. Once I'm close to it, doesn't have to be right on it, but get close to it, press enter, and the calculator will compute that intersection point. Now the calculator has done the best that it can numerically. You have to infer what this answer really is. It says that x is equal to 1.78 times 10 to the negative 14th power. That's really 0. And you can probably tell that the answer should be 0 just because if you plug in 0 for the x's in both functions, you get an answer of 3, which is what the y value was. So a should be 0. Let's go ahead and find the second intersection point. So second calc, intersect, also number 5. First curve, yes. Second curve, yes. Drive over to the other intersection point. And that should be close enough right there. Press enter. And it finds it at 4.5. Now sometimes your intersection points will not be nice numbers like 0 and 4.5. Let me show you how to store that x number in your calculator. Since this is the last calculation we did, I'm going to go to the home screen by pressing second quit. And now I'm going to press X store And since that was the second one, I'm going to press alpha B, since it's my second number. And that stores 4.5 as the B. We could have also done this after the first one, and I'll go ahead and do that now. It's not the X, it was 0. Store as alpha A. And now A is the value 0. Let's go back to the graph. In the formula for using an integral to find the area between two curves, you need to know which function is on top and which function is on the bottom. Here, the parabola that is opening down is the curve that is on top, and the parabola that opens up is the curve that is on the bottom. The parabola that opens up was y2, and the parabola that opens up was y1. What we want to do now is create another function in y3 that is going to be y2 minus y1. And in fact, we can actually just go ahead and type those in. I will go to vars, tab over to yvars, press enter for function vars, go down to y2 and press enter. Now, just like in algebra where you have f of x, the calculator expects y2 of x. So parentheses x, close parentheses. Now we subtract, and now we want y1. So vars, yvars, function vars, y1 of x. Press enter. And that is the equation of what we want to integrate. It's the top function minus the bottom function. Let's take a look at this new function on the graph. And there it is. It's also a parabola. Now, to find the area between the two curves, we're going to integrate from a to b of this new function. So I'm going to go to Second, Calc, tab down to number 7, integral f of x dx. The calculator wants me to integrate, but it's telling me to integrate the function that is y1. I actually want to integrate y3. So I'm going to press down, and that scrolls down to y2. I will scroll down one more until I'm on y3. Now remember that we stored the lower limit as a and the upper limit as b. So when the calculator wants to know what the lower limit is, I just tell it alpha a, press enter, and it automatically goes to 0. And now the upper limit is alpha b, press enter. And there is the visualization that is the shaded area under that curve. That area is also the area between the other two curves because of the subtraction that we did in creating the function y3. So the area between these two curves is 20.25. If you need to know what that is as a fraction, then you can go back to the home screen, second quit, go to math, and then press enter for change to fraction. What the calculator considers to be the last answer is in fact that last value that we calculated, 20.25. And 20.25 written as a fraction is 81/4. All right, thanks for watching.